So I wanted to use the slides, and there are slides for all the chapters that we're doing, except for the first the first two modules. I want to use these slides to basically talk about these bottom two times over here. We've learned constant time, linear time, and quadratic time. We kind of have a good idea of what cubic time would be. That's O(n) to the third power, which, by the way, is kind of like matrix multiplication. There any time you would get like 3 nested for loops. So logarithmic we'll learn during recursion, and this we'll learn during sorting and trees. But I want to talk about these two terrible times over here. You never want to have runtimes that are like this if you can help it. Sometimes you can't. Like with the traveling salesperson problem, there's really no way to avoid very, very terrible runtimes like this. There are just certain problems that actually are really difficult and really tough to solve. So O of n squared, O of 2 to the nth, that's exponential time, and O of n factorial, that's n times n minus 1 times n minus 2, and that's a terrible runtime. Let's go ahead and see what this looks like, right? So you've got your logarithmic time, and that's actually fantastic time. Logarithmic is basically whenever we take a step of the algorithm, we have the amount of work we have to do. Linear, we see you double the amount of work, you double the amount of time it will take. With logarithmic, you double the amount of items you have to do. Your work pretty much increases by maybe 1. So it's log linear is this nice, doesn't really grow too much faster than linear. Quadratic doesn't really look too bad comparison when we see exponential, which just simply goes into the stratosphere before we even hit 20. Right? This is a terrible runtime. Well, actually, sometimes it's fantastic and that really just depends on your point of view. But here we can see like different growth rates. Okay, over here like 50 to 100, and then the difference in the amount of time it will take, right? So if we double the size, so this is doubling the size. So doubling the size for O of n time will make it take twice as long. Doubling it for n log n makes it take slightly more than twice as long. So that's not really too bad. So getting log linear is almost as fast as log time. Sorry, as linear time. But O of n multiplies it by 4. O of n's cubed, 8. But doubling the size over here from 50 to 100. Yeah, that was a huge amount that it increased by. All right. So they don't really solve anything that's an an exponential algorithm or factorial. Takes a while. This runtime over here means that any additional input we give doubles the amount of time. 100 inputs, that takes an hour. Then 101 inputs takes 2 hours. 105 inputs, that will take 32 hours. So 2 times 2 times 2 times 2 times 2, 5. Okay. 114 inputs. This goes from an hour to 16,000 hours, which is almost 2 years, right? So now we can see when I was talking about the beginning about those programs need to be able to finish by the time you're still alive, I wasn't joking. Some things are really take too long to crack, which is a good thing because a lot of our cryptographic algorithms that we use to basically encode stuff, the n is to basically crack a password is the number of bits. So key length of 40 is considered breakable by a modern computer, but a key length of 100 bits will take a billion times more longer than a key length of 40. It takes 2 to the n time to crack a password where n is the number of bits. If we're just like brute forcing it, takes a lot of time. Any more bit of complexity adds just that much more time. So that's actually a good thing. So, sometimes we want things to take a long amount of time, like factoring, which is important for for breaking passwords. If you want to learn more about this and about runtimes in general, I highly recommend taking a look at this YouTube video, Computational Complexity Zoo, I think is it. Right, this one by Hackerdashery. This is a great video if you want to just learn it on your own. Okay, or learn more about this. This is fantastic.